It's been a year now since
Yeah. So so you will probably be able to.
no, it's the web code. It's not going to make much of I was wondering why would you get that?
What's the URL? Or what's the
should be
what's that?
core usage.
Sorry about that.
Let's have the projector.
Yeah, he's there.
Yeah, I mean, a big part of the development is if you do sort of fixed income products, a big part of the job is just getting calculating their values for the instruments. This is a lot of the time it's not just there's not just a market, it's a market. Like if you want to know what the price of Apple is, you just go to the market and get Apple. But a lot of the fixed income products, their value is actually mathematically quite. So there's a lot of interest rate mathematics and stuff that goes on to price these things. So that's one of the thrusts. I mean, but you're right. There's a lot of tooling around. Just decision making and trade-offs tools to make decisions and stuff. So.
Is there they call it video stuff as well.
Yeah.
The glass stuff. Like that is the reason.
Can we set up? Yeah.
Once I had it usable and I had time to figure out how to make actually wants to do.
Figure out what
he actually wants to do.
Obviously, you were flexible.
I want to do this, and I want to do this. Can you do this? I actually want to do this. Why?
Trying to set it up right now. No, I'm not. I didn't remember account.
All right. So,
language.
So D language.
Oh, great. That's hard. That's the live stream. All right, good stuff.
Oh, you were regarding
I'm not going to be able to get, if I get the full screen, I'm not going to be able to get much of you, I think.
Will that work?
Will you be sitting? Shall we?
Well, I think focus more on me,
Okay.
and I'll give you right now the PDF.
Okay. Send that to Ali, please.
Let's move the table so that you can easily get off the screen. Anyway.
Well, let's upload the slides. We'll put this on him.
Oh, I see what you mean.
Yeah,
And
yeah.
I will have to actually work with my
Yeah. So, do you have Ali's email address?
You should do this in this 5 minutes.
Yeah, it's going to take a couple minutes for it to propagate.
I'm wearing my Weka shirt for you to show.
I find it in my closet I was looking for it.
Yeah.
Still, it's fine. Just I think move me to the side of so that if I do. Right.
Is that okay?
Yeah.
Okay, send me the slides, please.
It'll
take a while for me to propagate.
Ali@yahoo.com. Ali.
Jehdeli.
Okay.
Serali.
Basically, just
Michael?
Mike Parker.
Is that the same URL as the?
No, say you can see working on the forums right now.
And give me a little time. Adding his slides.
It's an X40.
What?
Or ThinkPad.
The X260.
Oh, 260. Oh, it's
About 2 years ago.
all right.
Yeah, you're the right guy. Emacs, Lenovo, X style. You know. Yes, Shahar, you're okay with taking questions?
I prefer this.
It doesn't do what you want to do.
Ja, natürlich. No touching that one. That's
Yeah, sure. Are you recording? That's
yeah. That's the live stream thing. You can come over this side.
no.
I'm trying to push his slides right now. CI checks happening.
I'll run the timer, but you can feel free to.
Joyce.
Okay, good morning, everyone. It's the last day of the hackathon, and I noticed, boo-hoo. And I noticed the crowd's kind of light. I don't know how many. I don't know how many of the missing people are on their way home, and how many were victims of DConf last night. But we're live streaming today from my MacBook. Yes, thank you. Stephen has posted the link in the forums, so if you want to see the live stream live here, you can follow it. But hopefully the people watching from the forums will be able to get somewhat decent quality. So Shahar's going to re-announce Mecca. Thank you.
Is this on?
Yes.
Okay, great. First, allow me to do one thing. It's meant for synchronizing the audio between the two recordings.
Sorry, actually, it's not on. No, I'm on.
I think there's something. Is it now on? It's on mute. Muted. Testing one.
Okay.
Slides are up on your DConf page.
Okay, so for anyone watching remotely, we uploaded the PDF for the slides to
DConf 2018.
So go to DConf, go to the schedule, go to my lecture, and you should have the slides there, so you can follow as we can either capture me or the screen, not to both. Right. So my name is Shahar. Becca did not see fit to assign me a job title, so I picked one myself. And I'm here to talk about Mecca. So before that, I'll do a very, very brief recap of actually Liran's lecture from yes. Hopefully, I will not do a recap of Liran's part where he pre-announced my lecture today, because then we'll go to infinite recursion. So wake up. We're a storage company. So our product is a storage, which means that whenever your local disk isn't big enough to do whatever it is you want a system that provides reliability and high performance. We're a software only, which means that essentially what Weka will sell you is just the software. You're supposed to bring your own hardware. Due to technical or marketerial or whatever reasons, most clients actually want also hardware, so we partner with hardware providers to actually create a whole solution, but we're fine with providing only the software. That's the only part we develop. Not one or the other. You want very, very high throughput, or you want low latency. With storage, if you don't have both, then you don't have performance. Because if you don't have low latency, you're not going to get it through. Because even if you support a very high throughput with high latency, what you will find is that the clients do a request, wait for it for complete, and then do the next request. So if you're late, you're not going to get it through, no matter what the system's capability are. And it's written in D. The entire storage part is written in D. We have a very big QA team that works mostly in Python. About 280,000 lines of code. That is before the transition to Mecca. I'll explain later. And that doesn't include a single file that is 114,000 lines that was auto-generated. The tools. We're compiling using a build system called WAF, which is basically a Python program that does the dependencies. And to describe it in a single word, meta. You create a generator that creates rules, that create targets, that actually run the build system. And the changing things there is. So essentially, you'll note that in my job title at the beginning that I am chief, which suggests I'm not the only one. The project internal of the repository is called Wake Up. And like I said, we're extremely latency sensitive, which means that GC is a no-no. When we started out, we fixed for things that are very small. And then we found out that the problem with GC isn't the collection, it's the scanning. So it doesn't matter how often you need the GC, what matters is how much memory it needs to scan. And essentially, as little GC as possible was very crucial. And at the levels of latency that we're working, even the system calls are expensive. Now, that was the belief when we started out, 2014. They have since become more expensive because of the Spectre and Meltdown and stuff, and which means that today you actually context switching into the kernel when you do a system call. So system calls have actually became more expensive since. And data as little as possible. Ideally, and we're pretty much there, the data should arrive from the disk to the client asking for it without passing through the CPU at all. And for reading, we're reading without error recovery, we're pretty much there. And as you should know by now, microthreading, we're based on fibers, and originally on the D fibers. Now, I mentioned that that we're trying to get the data from the disk to the client without having it pass through the CPU. This driver I/O with them. So you ask for a block, and the NVMe DMAs the data from that block directly into your user space buffer. You use it to then tell the network, take this buffer and send it out. So essentially, we read it from the disk and then we send it over the network without the CPU having to look at the data and without a single copy, not one. I should point out that you've heard us complain about pushing it to the limit and being on the cutting edge and facing problems others haven't. We've done that to DPDK and SPDK as well. In fact, despite the fact that these two libraries are both by Intel and that they were built in order to work together, when we started out, we found out that they do not work together. You can do one or the other. So we're not complaining only about it, we're generally whining. So Weka ended up creating its own custom infrastructure. And it's worth explaining why. And the reason basically is, first, Phobos relies on the GC. VibeD, which I will give this disclaimer, I am not particularly familiar with, so nobody please get offended. But VibeD also relies on GC, as far as I know. And we wanted to do certain hacks in order to get as much performance out of the machine as possible. Phobos does not include a fiber scheduler. Basically, if you want to schedule fibers, you're directed to VibeD. And we needed the scheduler to work with the DPDK mode, which means a set. So we need something that could busy loop on one hand and still use EPOM for those things that we are doing through network sockets and the kernel. And basically, the standard libraries were not up to our standards in terms of performance. So, over the years, and we're talking about 3 years, 2.5, 3 years before the idea to start Meka started, we built a sort of internal ecosystem. Contained libraries with helpers for various stuff we needed. It contained containers that were non-GC, usually statically allocated, or in some cases using direct embedded to allocate memory from the kernel and use that. We had our own time handling, which was supposed not. The way it works is this. You have the infrastructure, and you have very smart people working to create the infrastructure. And then you have a developer who is still very smart, but he's not working on the infrastructure. He has a bug. And he debugs the problem and gets the root cause. And the root cause is that this happens like this, and this happens like this, and he needs to get something done. And getting something done requires that they change the infrastructure. So they do. It's the same source code. It's the same repository. And when they do, they don't sit down and say, okay, this is infrastructure. This is fundamental. What's the correct API to do that? What should we do so that it will serve everybody? They just put in what they need and continue because they have a bug to solve. And when they do that, they create technical debt. Trying to repay that technical debt. And in particular, in order for this problem not to happen again, or to reduce the possibility of this problem happening again, we decided to take the infrastructure and split it off into a separate library. So it's not the same repository, it compiles separately. And this way, the incentive to do a change because you use. Now, like I mentioned, Wake Up, we have this tendency to generate interesting names. So Wake Up is the product repository. We have it was called a BotiBot originally, but I petitioned to change the name to the Boty McBotface that closes bugs when. And since it's after Sir David Attenborough, of course, they called it Sir McBotface. We have Tekka, which is a tool for deploying machines through AWS and installing our repository with Dekka, which is essentially the same tool but running through Docker so that the versions are frozen. And the logical next step was Mecca. And we found out, to our surprise, that it's actually a name of a place. It's actually the name of a place, so we fixed the spelling. And essentially, it's a bunch of Israeli Jews calling a project Mecca. We're pretty much guaranteed to make everybody angry. But we figured if we called it New York, nobody would mind, so let the heroes in. Yeah, you did that already. And like I said, I'm not the only joker. Do I need to sing?
Yes. Sing.
The moment I wake up, before I put on my makeup, Mecca, that's our support library. Boost license. I caught up Marie and one of the founders, and I said, "What license should I release?" And said, "What are the considerations?" And I start saying, almost like, "Is there a problem?" I said, "No, I just need the power of attorney to do that." I said, "Whatever." So Boost license has a dub package, and the last point is because when you create an API, you have this great ideal in your head about how it should be used. What's the most convenient way to call it, to get the return, to handle the memory and the resources. And quite often, it crashes on the shores of reality. And the thing is, and I'll give you an example. When I created the file handling in Mecca, I used the same one that was in the internal code and in Phobos, that you do read, you give it a buffer, and it returns a range that is a subsection of that buffer, that is the part that was actually filled in. And as I started writing the unit tests, I began to have doubts. So I asked Tomer, who wrote the original code, I said, "No, don't do that, return length." I said, "Okay, you're reasserting my doubts." So I returned length, and then I started integrating that into the Weka code base. And what I found is that every single place, they would take the return value and take its length. There was not a single place where they were actually using the range. Pretty cool. For the past 2.5 months, what I've been doing is integrating the Mecca code base with the Weka usage. And in fact, I just got it to compile the day before I had to fly here. But what you're getting is API that is actually integrated into 280,000 lines of code minus the code I ripped out because it was duplicated with Meka. Which means that it's not that it's ready, and in fact, at least in the near future, I will make breaking changes if I think they're correct. We don't want to repeat what happened with C and the single ampersand operator, where they said, oh, well, bit operations are much more important than log. It's too late because there were 20,000 lines of code that were using it. You don't want to break 20,000 lines of code, right? So I will be making breaking changes if I think that the current API is wrong. Meka was built at this point to support the Weka code base, which means that that's where our effort was and is focused. So right now, it only works on Linux. It only works on 64-bit Intel platform. And going forward, I will happy to have contributions, and I will happy to have these two restrictions lifted. But at the end of the day, Meka, I think I'm going to stop using Meka has to be useful for the Weka code base. Now, thankfully, I don't think that's because the Weka code base isn't that unusual. And if someone brings in a change, and that change is conductive to making Meka better, then it will probably make Meka better for us as well. So I don't think there will be a conflict. But fair warning up front. That's the code, you've already seen that slide. So with that last warning in mind, I wanted to start with the logging facility. And the logging facility looks like this. You do debug or warn or info or whatever, and you give it the format string as a template argument, followed by the actual arguments to the function. The reason this is the way it's done is because this is actually preserving interface from our own internal tracing mechanism that, at least at this point in time, we're not yet releasing. And this is meant for binary logging. And the template, instantiating the template for each instance, and it's not only this instance, because even if you have another debug in your program that has the same format string, which isn't unlikely, because sometimes your format string is %s. It will not be the same instance because the file and line get also part of the instantiation. And this allows us to assign a unique number to each instance and not log the actual format. The actual format isn't part of the tracing. And so it's a bit of a weird mechanism, slightly counterintuitive. I think it has its own advantages. Meka does come with a logging facility that supports that, so you will actually get a log. And I'm hoping over time to actually get it to be stronger. And there's some hope that we'll actually be able to one day release the actual tracing mechanism. So that's one price you do pay for that. Also, you'll notice the no trace user-defined attribute at the beginning. That only does anything for our tracing. What it does essentially, the tracing automatically logs entry and exit to the function. No trace shuts that down. Says this function should not be automatically logged. So it's there. It doesn't do anything for the current Mecha system, but it's otherwise harmless. By the way, if you have questions, interrupt me. Really important. So show me the code, right? Okay.
A little larger, maybe?
A little larger, why not? Good enough? Someone help me out here. So we created a new project.
Maybe a little bit bigger still, please.
I think that the interesting stuff.
A little larger font, please.
Okay, so let's put it here. Font, and we want. Is that all right?
Yeah, much better.
Okay. So we don't want SO, we want Metalog. And we want the Mecha reactor. The reactor is, like I said, scheduled. The basic program is this. Reactor, a setup. The reactor starts, and you can just return its return value if you want. That's the most basic program, and what it does is who needs to compile when you have something what's actually what it does is nothing, because we haven't told it to do anything. You will notice these lines. Mecha runs with the GC turned off. So every so often, and I think the default is 30 seconds, every so often it allows the GC to run so that you don't accumulate too much junk. But the GC will not run inside your fibers. That's part of the design. The technical reason for it is that the fibers run with their own stacks, which are not quite big enough, and there's not always enough stack to run the GC. So if you try to, it will cause a segmentation fault. But it really suits us that we're able to control when the GC runs. Also, not yet in Mecha, but will be querying the GC statistics in order to not run the GC if there were no allocations. Yeah, right, okay. So what we want to do is actually spawn a fiber. not a very interesting one. One thing I want you to notice is that when I log, I get the fiber number, the fiber ID of where the log came from, which is my incentive to you to use this logging facility and not right away. So we say that fiber ID 3 was launched, and then it printed my message, and then it asked the reactor to shut down. The reactor shut down orderly, but exited with exit code 17 because that's what I asked. Let's do something a little more interesting, if we think we can. Let's open a socket.
We have a question.
Yeah.
Hey, I saw that it spawned 2 fibers. Why? Because I didn't see a fiber in the one by
Yeah, there is some overhead that the reactor itself maintains. I actually do not remember what that fiber does, but I can look it up. But I'll have to look at the source. I don't know. But some operations spawn extra fibers. Generally speaking, those fibers sleep. There's one exception for when you defer execution to a thread. There's a timer which is too frequent for my liking that polls whether any of the threads whether any threads have finished its execution. So I have another import called Mecha Reactor IOFD, and the reason it's under the reactor is because this FD is reactor aware. So we're using a blocking interface as far as our code, but it will not block the operating system level. And what we do here is let's put a listening socket. Now let's actually do something. Except if you read the operating system man page, gets a socket with the client's IP address. Since getting it later is possible but requires an additional system call, that's also what accept does here. Yeah. Right. Okay. And we see that we got a connection from the address, but we also see that the connection immediately terminated. Do you see why?
It's the scope.
Right. The client socket went out of scope. So when you get a socket, the socket is self-maintained. It has a destructor that will close the socket and deregister itself. And since we create the socket here, but after we print it out, it goes out of the scope, the connection closes. So we want probably something more interesting. And since we want to support a large number of connections, what we will do is, do I have to explain this line, by the way? I want you to think about that answer. I wrote something in an API you don't know. Nobody needs an explanation. So let's look at the client fiber. The client fiber will get the client sockets. Anybody see a problem with this problem?
By value, by reference?
Well, I think it's pretty obvious that it's by value.
Is it a reference type? I don't know.
Anyone?
Well, what happens when you put that socket? Is it ref counted or?
The answer no, it is not ref counted. What it is, it is uncopyable. So it has disabled this, and so I made a mistake, and the mistake doesn't compile. In order to get it to compile, what I need to do is this. I can move the socket. Anybody here not familiar with the move from STD algorithm? What move does is it says, okay, this struct is not copyable, I get you. You transfer ownership to someone else. So after this line in the code, if you try to look at client socket, it will have the init value. It no longer is part of the listening fiber. And instead, it now belongs to the client fiber. And I think the most remarkable thing about it is how unremarkable it seems, but I just took a local variable from one context and moved it into something that runs in a completely different context. And if we want to do something more interesting, now we can do Amazing. And we have an echo server. And originally at this point, I wanted everyone to connect to my computer, but I found out that the hotel was actually quite diligent and their Wi-Fi blocks people connected to the same Wi-Fi from connecting to each other. So you can't. But I really wanted to hammer the server because it's 42 lines, start to finish, and it supports any amount of connections that my computer can have. Stefan.
Will it be thread side? Will it be thread side to do this in multiple threads?
No. At this point, the question was whether it will be thread safe. At this point, the reactor is built to work on a single thread, but there's nothing inherently preventing it from being thread safe. So it's an extension that the API supports. The code currently does not support, but the API supports. Now, this code actually still has a little bug. If we call the reactor code, if it calls a fiber, and the fiber throws, the reactor can never be sure whether that was intentional or not. So, in order not to cover up for errors, if the fiber throws, the reactor forwards this exception to the main thread, main fiber, and exits it, rethrows it. So your fibers need to never throw outside the main fiber code, with one exception. I'll get to it later. So if we wanted, because what happens here is that if, for example, we did read and we got a IO error or pipe or whatever, if read failed for any reason, then this would throw an error and the client fiber would not catch it and the reactor would exit. So if we want to fix that bug, we need to close everything with a try catch. So once we did the initial coverage of how this even looks like. Oh, okay, one more coding before that. Sorry.
Shahar, are you done with coding?
For a little while, yeah. Let's do one more change. If I want to support, whenever I see an API that looks too easy, I get suspicious because sometimes you call one line and get an echo server or an HTTP server or something that does lots of interesting stuff. And then you say, or even just opens a socket with single function call, really, really simple. I say, yeah, fine, but when you look at that line translates to 3 or 4 system calls. You have to call socket in order to create the socket. Then you have to call bind in order to bind it to a port. And then you have to set various socket options on it. And everything is within this single simple line. And when I call socket, I can tell it to create different address families. And what I like about this is that all that flexibility that is when you do the actual system calls, is still there. If you want a different address family, just take it as a different address family. Instead of SOC ADDR IPv4, you can have a SOC ADDR IPv6 or SOC ADDR Unix. Of course, if you did SOC ADDR Unix, you're going to have to give it a path rather than it has no any address. In fact, I can do something else. I can do this. And then I can do this.
That's what you had for
I didn't hear you.
half
Oh, right. Got two listeners. Ah, that's right. Yay. Okay, we're not going to start the debugging here, but by the way, yeah, that's actually a bug in the. I should fix that. The reason you're not getting the vectors here, I believe, I only figured it out a couple of days ago, is because this was thrown not from the fiber that created the error, but from the fiber that from the main fiber, because this exception was forwarded. And that's obviously for errors, that's obviously a mistake. So that's a bug fix now. Not now, but we have a hackathon. There's a range error somewhere here. But the concept still stands. The abstractions I'm using are fairly close to the abstractions that the operating system holds. And in fact, when you read the socket API, you kind of get the feeling that they wanted to use inheritance between socket ADDR and socket ADDR in, and they just didn't have the facilities for that, so they didn't. And here it's not exactly inheritance, but because there's just structs and not classes, but that's what I'm doing. Okay, back to the presentation. Any program needs to know what the time is. It's something. And the problem is that going to the kernel, like I said, is very expensive. Sometimes you need to know what the time is fairly frequently. And Get Time of Day did this strange hack in order to reduce the cost and give you the time without going to the kernel. And the thing is, we benchmarked it, and it still wasn't fast enough for us. So in order to keep track of time, we're using our own struct called TSC time point. Everybody doesn't know what the TSC is? Okay, surprising if the number was smaller. TSC is a counter that on Intel CPUs that is kept internally. It essentially counts how many clock ticks there were. And originally that's precisely what it did, and then the CPU would step down the frequency because it was idle, and the counter would change frequency. And people said, no, that's unusable, and say, okay, right. And they fixed that, and they even guarantee that if you query the TSC and you get a number, that number will remain consistent even if your thread migrated to a different core. And when I say big guarantee, I mean big promise. I don't think that actually happens. So we're using TSC time point, and the downside is that the kernel does not export. Yeah.
When did this guarantee introduced? Because my understanding was that TSC would be relied upon across different floors.
If that's still the, I don't know. Okay.
Well, I guess follow-up question: Can fibers actually keep migrated across floors?
You know, time flies like an arrow. Fruit flies like a banana. As far as I know, that is guaranteed, but I can't say that my knowledge is authoritative. So, and the problem with using the TSC to keep time is that you get a nice number that keeps increasing, but there is no official facility to know how much that time that is. So essentially, and the kernel measures that number, it just doesn't export it in a way. So what we're doing now is not optimal, but it will do for now, and we have plans to make it better in the future. What we're doing now is that we have a static base that measures what the TSC frequency. And the bad news is that the way it does it is by taking the TSC, sleeping for 300 milliseconds, and taking the TSC again. So at this point in time, any program that uses Mecha has a minimum 300 millisecond startup. Like I said, there are plans to fix this, and when we do, it will be dramatically smaller. And essentially what we will do is we take an approximate value and keep improving it as the program runs. And that means that the TSC frequency will change during the program. Because right now, if you ask what the frequency is, it gives you an immutable value. So don't rely on its immutability. This is also important because we found out that the TSC isn't as fixed as we'd like it to be. We found out that it actually, if the program runs for long enough, it changes. One important point about the TSC is that the TSC time point is not a reliable way to measure long spans of time. If you want something that is very far in the future, it will be unreliable. Linked lists. This is the Mecha linked list implementation.
We have a question.
Yeah.
What's my question? Have you tried using the high precision timer facilities which are available on modern systems?
I don't know the details, but as far as I know, that's that.
I don't think so. I think the high precision timer is a different mechanism from the TSC. The TSC
is it exported to user space?
I don't think so.
Right. Linked list. Nothing can be more boring. Our linked list is a doubly linked list with an optional owner. And it's cyclic. So the head points to the tail and vice versa, which means that the linked list header, the linked list is a single pointer to the head. And which means that embedding a linked list into a struct is really, really, really cheap. In fact, since everything is templated, it doesn't really even have to be a pointer. It just has to be something that you can extract a pointer from. For example, if you're using a pool to allocate the nodes, it can be an index number into the pool and be even less than 64 bits. So it's fully functional. We can get the head, we can get the tail with O of 1, but it's very cheap to store. Now I've got a question for you. How much are 6 boys plus 3 planets? Okay, nobody seems eager to answer. I'll ask you a different question. Do you agree with me that the answer is not 9? Does anyone not agree?
It's 9.
It's 9. Okay. Ali, please close your eyes for the next slide. The problem is that this code compiles fine. Nothing to indicate to the compiler that we did something stupid. So we introduced something called the typed identifier. Essentially, you can very, very concisely define new types that are not convertible to each other. So essentially, it's not very different from what D tried to do with typedef, except that since we're not a language facility, we don't suffer from the same restrictions on what we have to promise and what we have to do. And so we can get away with it. And this code doesn't compile because it says, I don't know how to convert boys to planets. And that's very useful to stop yourself from making silly errors. For example, we've got a type identifier, and not only for making silly errors, but it also makes your code more concise, because internally we've got a type identifier that is called disk ID, that identifies a disk in the cluster. And we have another type identifier that is called disk index, which for a single rate stripe tells you which numeral it is. And the function to convert from one to the other is called disk index, convert disk index to disk ID. Well, no, it's called 2. And the thing is, I think everyone who's ever worked with D knows what this function does. It doesn't need to be more verbose. And it's type safe.
Is it a coding style that you don't put to disk ID at the end? You guys don't like it? Disk index to disk ID, UFCS.
I don't like it. We have an entire day of hackathon to discuss it with everybody who's now angry at me.
We have a type there for the capital team, type ones. So what is the distinction between type and that type?
It is loggable. It is loggable and it is searchable with our tracing facility. Essentially, also, there are 2 types of type identifiers. There are the usage types and the algebraic types. And we would have created more subtypes, but I said, let's start with those 2. Essentially, an algebraic type, you can do disk index plus 3. Because I'm on the 2nd disk and I'm on the 5th disk of the stripe. But you can't do disk ID plus 3 because it's just a random identifier. There's no, it doesn't make sense to do algebraic operations on it. So there are finer distinctions that we're making that would be more difficult to do with the language facilities.
Yeah, there are very good reasons to not use universal function code syntax when you want to write code that's actually understandable and maintainable, because if this IT for some reason had a function called to that would override the UFCS and not conflict. So yeah, that's one of the features that sound very nice but are bad for maintenance.
Let's keep that discussion offline because I'm running past my deadline right now as it is. To skip include here because it's cool, so we can skip it. Keeping track of time. A reactor needs a way to say sleep for 3 seconds, or give me a timeout. Or all blocking operations we saw read earlier accept an optional argument that says timeout. And if you try to read and you didn't read for that amount of time, an exception is thrown. The timeout expires, exception is thrown. So you can create your code, and I'll show it later. You can create your code very simply that doesn't read forever. If a client opened to our server and it is just sitting there, it's not sending anything. Maybe we don't want to let him stay forever. Maybe we want to kick him off. And keeping track of time is a very complicated matter, and we're used, I think the kernel, Linux kernel uses that as well. Essentially what we have is a list of buckets. The default for the reactor is 256 buckets. Each one of those is a linked list, which is cheap because linked lists are cheap. And each one of those represents a 1 millisecond time interval. So we say our accuracy is 1 millisecond. Oh, you say, but what if I want something that happens more than 256 milliseconds in the future? Well, there's a second level. The second level, each bucket represents 256 milliseconds. And whenever we finish the first level, we take the next bucket from the second level and spread out the events in it. So we clean out the list in the second level, and each one places the correct bucket in the first level. And that brings us to, I don't remember how much exactly. That brings us to a few seconds, if I remember correctly. What happens if you want more? Well, we've got the third level. And in the third level, each bucket represents about 65.5 seconds. And we also got a fourth level, where each bucket is for 4 minutes and 40 seconds, give or take. And we don't have a fifth level, that makes sense. That's already 5 days. And you say 5 days is a lot, that's great. But, sorry, 49 days. So before I continue, what's the big O complexity of putting a value in the time queue?
Constant. Constant.
It is all of the number of levels actually. So scanning a bucket and distributing the events in it depends on how many, is linear with the number of elements in the bucket. But if you don't look at the effect of that single operation, but in the context of the overall system, when I put an event, it is going to be spread down at most 3 times. So spreading down a single bucket is big O complexity of n, but it is amortized O of 1. So 49 days, and you say, fine, but I was really hoping to get a timeout that will remind me to go out and watch the next blue moon, which is sometime October 2020. So what about that? We have another bucket, single bucket. And the idea is that very few events will need it. So every time we finish, once every 49 days, we scan this bucket and say, okay, these events need to stay here, these events can go into the cascaded time queue and get more accurate. So think about it. If you ignore the TSC time point inaccuracy for such long events in the future, you can schedule an event for 3 years in advance and get it scheduled with 1 millisecond accuracy. Another thing we do here, we keep track on when the next non-zero event is. And the worst we have to pay for that is we need to scan 1024 lists. And this means that when we go to sleep to the exact amount of time until the next event. We may have to wake up in order to do the cascades, but at most that will be 3 times. And this means that the Mecha reactor has achieved something that the Linux kernel still hadn't, which is truly tickless. There is no ticking that we wake up to handle. We wake up when we need to. Like I said, Mecha has its own fiber implementation. Really, really quickly. A fiber is a facility where instead of in the kernel, you use user space in order to keep simultaneous or pseudo-simultaneous code running in parallel. And the way you do that is by you run one code, and when that code decides it needs to sleep, that's why it's called cooperative multitasking. When that code decides it wants to sleep, you just save all its registers somewhere and load another fiber to execute. And there are 2 modes of operation. One is that you have a main fiber, and it jumps into the current execution, and when that execution sleeps, the function returns, and then it schedules another fiber and jumps into it. That's one mode of operation. That's the mode that the D fibers work in. And that means that you have to replace the register set twice for every context switch. So we didn't want to do that. Instead, our fibers switch directly from one another, and the scheduler runs inside the context of the fiber that is losing the signal. So we have our own fiber implementation. Also, something that is just an anecdote. Since switching between fibers is a function call, the ABI says that when you call a function, some of the registers the function has to preserve, some of the registers the function can use for its own use, and if you want them to remain the same, you have to store them. Since our context switch is a function, we don't need to save all the registers because some of them the compiler already knows it has to save itself. So we save only those registers that the ABI say we may not clone. Also, and this you need to know, we do not save the floating point registers. Which means that right now, it is not safe to keep floating point operations around when you might sleep. Fortunately, the reactor has a facility called critical section that you say, okay, this code must not sleep. You say enter critical second. It does not prevent the sleep because it can't. But if someone tries to sleep, it will assert. So it will prevent you from entering a bug. This is the generic how you schedule finders. That's how you do it. You have a function that is supposed to block. You call that function and you check the return type. If the return type is a failure, and the failure is either E again or E would block, that means that you can't finish the operation right now. You have to wait for something to happen. So you call a function that lets the operating system know that your equal listener or queue or whatever need to wake you up when this file descriptor has room for your read, has data for your read, and you deal you will keep being woken up, but you don't have any fiber that needs the file descriptor. Then you retry the read, and it will now probably succeed, and you can go on with your life. Now, this means that for every read that I want to do, if I have the data, that's one system call. If I don't have the data, that's 4 system calls here, plus the actual equal. Now, the actual equal I don't count as a complete system call because that equal isn't listening only for my FD, it listens for others as well. Let's call it a half. So that's 4.5 system calls. Equal said, well, we realize you probably want to deregister. They have a mode called one-shot. And with one-shot, the operating system automatically deregisters any file descriptors it let you know about. So we're down to 3.5. Equal also has something called an edge trigger. Edge trigger works like this. It's an expression from electrical engineering. I had some electrical engineering background, and it was very intuitive to me. And then I started talking to people, and I found out that software engineers generally don't know what that means. I'll try to explain it here. What we have, this graph tells us whether there is data waiting on a socket, for example. So initially there is no data waiting, and if that socket is registered on an equal, and we call the equal wait, equal will block. Now, at this point, data arrives, and that equal will wake up and will tell us, okay, there's data. And then we read the data from the socket, and we read all of the data from the socket. And at this point, if we equal wait, it will block again, because there's no data on the socket. Until more data arrives, and we read it again. And then the Linux kernel said, wait, we can save you a lot of system calls by not triggering on the level, whether you're up or down, but on the edge, on this edge of edge going up from 0 to 1, that's our trigger. So, at the point at the beginning, equal blocks, data arrives, equal doesn't block, but once we read the data, equal doesn't block. And then when we consume the data, actually we didn't know that we consumed the data. We only know that we consumed the data if we try to read and get it E again. That's how we know the data was consumed. So during that E again, the file descriptor gets armed, and the next time data arrives, people again will wake us up. The thing is, when I first read about this model of operation, I said, what? So I'm supposed to keep track of whether I got an E again or didn't get an E again, and then figure out whether I can or cannot trust people to wake me up. No, I'm going to use that trick. It makes no sense to start keeping track of what the kernel told us and didn't tell us. I'd rather make the system. And it doesn't. Unless you're using the standard fiber switching. You enter the read, and probably the file descriptor isn't armed. Because it turns out it isn't armed when you exit. So you enter the read, and people will not be listening on the file descriptor. And then you perform the actual system call read. And the actual system call read will either succeed, in which case, great, we don't have to sleep, go out of the function, we're done. And the FTD still isn't armed. Or it will fail with E again, in which case we need to register, we need to arm the state. We need to say, okay, people needs to tell us about this file descriptor, but it returning E again already armed the file descriptor, so we don't need this system call. And then we yield, people wakes us up, we don't need to deregister the file descriptor. So essentially we're down 2.5 system calls, which are essentially just the read and the read. And it may not surprise you to know that Mecha uses edge trigger with the reactor.
Okay, thank you very much. Does anybody have any questions for me? Can you keep that going?
It's not a question, but I wanted to thank you for like showing the code that was a great to show my presentation about the edge trigger and the understanding of the also. Thank you.
So you said that your speed fibers out like one from the other. So essentially, if you have a program from the thread, you see multiple fiber stacks.
Because every time you switch fiber, you also switch the stack pointer. Each fiber has its own stack, and you will only see that fiber's stack pointer in the vectors.
So still replace the whole context. Anyway, we can go.
Okay.
So much. Okay, thank you.
Any more questions? All right, thank you, Sean. And thank you, Ali, for watching the live stream here. Okay, I hinted before on the blog about a new initiative, and I guess today I get to announce it. We started the page at Open Collective a few weeks ago, and we were trying to figure out ways to use it, especially for targeted funding. And luckily, Open Collective recently added support for goals. So we're going to be able to use that to start setting goals to fund specific initiatives within the community. And as a starter and a test project, we're going to set a target for $3,000 to fund the Visual Studio Code plugin, the Code Serve plugin. So if we get $2,700 within 30 days committed to the goal, the foundation will make up the remaining $300. We will give that to Web3 to do as he needs to do to meet milestones and improve the plugin. And if this works, we're going to continue to do it We can fund other projects in the community. We can set up funding for core development and everything else. We're trying to overcome our problem of no resources. And this is one way we're going to try to tackle it. So, Sebastian should be able to set that up pretty soon. And you'll be able to donate as much as you want. Every little bit will help. And once we get that $3,000 goal, Web3 can use it as it needs to. Also, during the hackathon today, if you're looking for something to do, the Bugzilla, anything with a boot camp in the label, a boot camp label, is fair game. It shouldn't be too difficult to solve here at the hackathon. And I believe, Bob, you wanted some help.
Good morning. Like I introduced a bit yesterday. So today I'm gonna look deeper into some bioinformatics tools and want to convert or do some or solve some problems in this Rosalind website, just to produce more example of writing the code to solve bioinformatics problems. So if you would like to give
And Ethan, you have at least one person who is eager to work with you on a live group. Yes. And if anybody else has any projects you want help with,
feedback on the op move. I would love to do.
Yes, he wants the op move dip that he is currently in draft. He wants feedback on that, and of course, you're welcome help with Mecca. Stefan?
You can help. You can help music if you want to. I will be here for a few hours, and I can tell you what it does, and we can go over the design. But of course, you can give me funding, which would be nice.
I think that was an official application for funding.
Me and colleagues, other singers from UBD, we're going to keep like a workshop for high school students about D, and we want to make them code a bit with D. We were thinking about making a game, small game, maybe a snake or an X0, if you don't have any experience with game development, so there's someone very cool.
Gee, I wonder.
Who wants to give us a hand? Nothing about you, work.
No pressure.
Okay, anyone else? Okay, and I'm always looking for content for the blog, so if you want to talk about that, find me sometime during the day, I'll be around. Dips, if you want to talk about the dips, we can do that too. And I'm about to lose the audio pretty soon, so I want to say once again, thank you all for coming, and I'll see you through the rest of the day and next year. Thank you.